For this module, we'll be discussing indeterminate forms and the application of the L'Hopital's rule. What are indeterminate forms? Basically, indeterminate forms, there are 4 cases. However, the most common one is either 0 over 0 or the infinity over infinity. So the limit of a function as x approaches a certain number, when it becomes 0 over 0 or infinity over infinity, we still can evaluate this, diba? This was taught to you in quiz number 1. Like, we'll try to look for ways in which we can evaluate it. However, there are several other techniques in evaluating this one, such as the one that I'll be teaching you later on. First, let's try to evaluate the following. For example, this one. I'll just write on the side. The limit as x approaches 0, e to the 0 is 1 minus 1 all over 0. So this one is 0 over 0. This is an indeterminate form. The limit as x approaches 0 for ln of x, this one is, on the assumption that this one is, let's just say, this one is from the positive side. That becomes negative infinity over 0. Take note that when you are evaluating limits, guys, 1 over 0 is infinity. 1 over infinity should be 0. So in this case, I can say that this one is basically negative infinity times infinity is simply negative infinity. This one, oh, it's difficult if it's a negative exponent. So what we can do here first is make it like this. Positive infinity. So this one becomes infinity over e raised to infinity is also infinity. So this one becomes an indeterminate form. And, you know, I'll just ask you to try solving the rest. But how do we evaluate the indeterminates? First, it's important to know what cases there are, or what cases they fall under. Look at number 1. Number 1, this is what you call the first case, wherein you have either 0 over 0 or infinity over infinity. Case number 2, it's a product of 0 times infinity. Number 3, since you don't know what infinity is, if you subtract infinity from infinity, it is indeterminate. Next, you know that any number raised to 0 is 1, except for 0 itself. Because any number raised to 0, you know that that's 1. But 0 raised to 0, it cannot be 1. That's why this one is indeterminate. Infinity, you know that that's a very, very big number. Raised to 0, it cannot be equal to 1. So this is also indeterminate. And you know that 1 raised to any number is equal to 1. However, 1 raised to infinity is indeterminate as well. So please take note of the 3 forms and the 4 forms. However, the last one, the case number 4, there are 3 types or 3 examples. Okay. We'll be going to the L'Hopital's rule. So let f and g be functions that are differentiable on an open interval. So whenever you reach 0 over 0 or infinity over infinity, what we can do is we apply the L'Hopital's rule. So what is L'Hopital's rule? Basically, obtain the, look at this, obtain the first derivative of the numerator and then obtain the first derivative of the denominator, but you do not apply the quotient formula or the, you know, the product formula. So that's why in here, do not apply product or quotient rule. Actually, there should be slash quotient. And then L'Hopital's rule can be applied to one-sided limits as well. And then L'Hopital's rule can be applied multiple number of times. So more than once, it's still possible. So what is L'Hopital's rule? Let's try this one. For number 1, if we apply the limit as x approaches 3 for x squared minus 9, x minus 3, this becomes 0 over 0. So this one is what you call type number 1. So what do we do with type number 1? Sometimes when we took up limits in first quiz, what we did was, let's try factoring it out, right? We tried factoring out the top and then factoring out the bottom, and then maybe we can cancel out terms. Yes, that's the way to go. However, I'll show here that we can apply another technique, which is what you call the L'Hopital's rule. According to the L'Hopital's rule, we still keep the limit, but then we get the derivative of the top. What's the derivative of the top, guys? 2x. The bottom is 1, right? Therefore, when we apply, that means the limit is 6. Let's try the second one. The limit as x approaches 0 of sine x minus x over x cubed. So sine of 0 is 0 minus 0 over 0. So obviously this is type number 1 or case number 1. So according to case number 1, if it falls as either 0 over 0 or infinity over infinity, we apply the L'Hopital's rule. What is the first derivative of sine, guys? Cosine of x minus 1 over 3x squared. Okay, let's apply. Cosine of 0 is 1 minus 1 over 0. So it's still 0 over 0. It's still a type 1. So long as it's type 1, maybe we can apply the L'Hopital's rule once more. That becomes negative sine x over 6x. Let's apply. Negative 0 over 0. It's still a case number 1. Maybe we can apply L'Hopital's rule once more. So, negative cosine x over 6. Let's apply. Negative cosine of 0 is 1, and then there's 6. So that means the answer is negative 1 over 6. So that means you can apply L'Hopital's rule multiple times. In this case, you applied LHR 3 times just to obtain the answer. But it is essential that before you apply LHR, it has to be case number 1 or type number 1. All right, let's go to number 3. Number 3, limit as x approaches 0 of e to the x minus the ln of 1 plus x minus 1. It's quite an ugly example. It's quite long. So e to the 0 is 1 minus ln of 1 is 0 minus 1 over 0. So we end up with 0 over 0. So this is type number 1 or case number 1. Since it's case number 1, what can we apply, guys? LHR, the L'Hopital's rule. Okay, applying this, I'm just copying the limit expression. This one is e to the x minus this one gives me 1 over 1 plus x, and then that becomes 0 on the right. And then this becomes 2x. So let's apply 1 minus 1 over 1 plus 0 over 0. So minus 1 minus 1 over, so it's still case number 1. Maybe we can still apply another L'Hopital's rule. So that's e to the x. So that's plus 1 plus x squared all over 2. Okay. Let's apply 1 over 1 all over 2. So 2 over 2 is equal to 1. That is the answer. The limit is 1. But you know, to get there, we have to apply L'Hopital's rule twice. Next, this one's quite, ugly. But I'll start with number 5. I'll skip number 4 for the meantime. Maybe we can do that some other time. I just like number 5 example. Because number 5, as it is, it looks bad. Maybe what I would suggest, guys, is if you can transpose some of the terms, or you can put some of the terms in their proper places, just like this. At least we don't have a negative exponent. So with this, it becomes infinity over infinity. Okay, still type number 1. It doesn't matter. And then what we do here is we apply the L'Hopital's rule in here, in the transformed one. So that's 1 over e to the x as x approaches infinity. So that's 1 over infinity. What's 1 over infinity, guys? 0. Very good. Therefore, the answer for that is 0. Now, let's go to case number 2. Again, case number 2 is the product. Whenever you have the product, we would want to make it a quotient just like this. The goal of the indeterminate forms is that whenever you get any other cases, case 2, case 3, case 4, we need to transform it to case number 1 or type number 1. So just like this. Okay, for number 1, let's apply. As x approaches 0 from the right of x, ln of x. So this one would be 0 times ln. You have to remember, guys, that the ln, the curve of ln is like this. If you can still recall, just like that. So what you'll notice with ln is that it does not have any graph on the negative side. So this line right here is actually an asymptote. So as you come closer and closer to 0 from the right side of it, it actually is going to negative infinity. So this one, you can say, okay, that's type 2 or case number 2. So for case number 2, we need to transform it to a quotient as well. So what do we do? With me personally, I don't put the ln underneath because it becomes more complicated. What I do is this. Ln of x, and then this is 1 over x. So that when I plug in, this is negative infinity. Guys, what's 1 over 0? Positive infinity. So this one is transformed, guys, from type 2 to type number 1. Since it's type 1, what do we do, guys? The LHR, right? Okay, what's the derivative of the top? 1 over x. What's the derivative of the bottom? Negative 1 over x squared. I would recommend, guys, that even before you plug in everything, maybe we can arrange this. This one could be arranged in 1 over x times negative x squared over 1, right? So that means when I apply the 0, it's just negative. The answer is 0 pala. So that means even before you apply the limits, maybe you can simplify the terms. So it makes your life easier. Okay, let's go to the second one. The limit as x approaches pi over 2 of tangent x, ln sine of x. Okay. Just to remind you guys, pretend this is 0, this is 90 degrees, this is negative 90 degrees. So that means this is 45 pi over 4. This is negative pi over 4. Okay, guys, what is tangent of 45? What is tangent of 45 if you remember? It's positive 1. Am I correct? Tangent of negative 45 is negative 1. What's tangent of 0? 0. What is tangent of, let's just say 60? Square root of 3. Di ba ang square root of 3? It's a bit smaller than 2, but a bit greater than 1. Let's just say here. And then the other one, somewhere here. Kunyari, this is 2. The shape of tangent, guys, is like this. Like that. So, if, for example, you want to extend the graph, it's like that. It's like that. Okay. So, what is the tangent of 90 degrees? It goes to positive infinity, right? If it's a bit less than 90, so this is 90, a bit less, it's to the left of this. That means it's going to positive infinity. So, sine of pi over 2, what sine of pi over 2? It's 1. Ln of 1, that's 0. So, this is type number 2. If it's type number 2, we need to transform this to type 1 or case 1. So, that's ln sine x over, if it's tangent, I put it below, that becomes a cotangent. Am I correct? So let's apply. This one is 0 over. The reverse or the inverse of infinity is 0. Am I correct? So guys, what is the type now? Type, very good. This is type number 1. So if it's type number 1, we apply the L'Hopital's rule. 1 over sine x, and then the derivative of sine x is cosine of x. Okay, we're finished with the top. The bottom cotangent is negative cosecant squared x. So again, it's all trigonometric. So what I would do, guys, is maybe I could simplify this first. This one is cosine over sine. Cosecant squared, guys, if I put this on top, what will it be? Am I correct that it's sine squared x, and then let's just put the negative in front? Am I correct here? And then I can simplify the whole of sine x and then that one. So that means I am actually evaluating negative cosine x sine x. So from this ugly term, it can be simplified into this. Okay, so let's do this. Cosine of 90 is 0. Sine of 90 is 1. So the answer is 0. Okay. Yeah, guys, infinity times infinity is still infinity, okay? Take note of that. Infinity times infinity is infinity. All right? 0 times 0 is 0. Okay, let's go to case number 3. Case number 3, guys, is this. Infinity minus infinity. So how do we do this? It says here, transform to either this or this. Okay, let's do this. The limit as x approaches 1 from the right of x x minus 1 minus 1 over ln of x. That's 1 over 0 minus 1 over 0. So it's infinity minus infinity. What's the case, guys? Very good. Type 3. If it's type 3, maybe, guys, whenever there is a fraction, maybe you can combine the terms. On top, it's x, ln x minus x minus 1. So it becomes plus. So let's try. When we plug in, it's 1 times 0 minus 1 plus 1 all over 0 times ln of 1 is 0. So in here, you'll have 0 over 0. It's already transformed to type number 1. Since it's already type 1, guys, we can apply the L'Hopital's rule. For the L'Hopital's rule, it's a product on top. So copy the first, derivative of the second, plus copy the second, derivative of the first, minus 1. The other one is 0, so I don't need to write that. Here, it's also a product. Copy the first, derivative of the second, plus copy the second, derivative of the first. Okay, let's apply the limits. This one is just 1, because that's x over x. Minus ln of 1 is 0, minus 1 over 0 plus 0. So you'll have 0 over 0. It's ugly, right? But it's type 1 still. So here maybe we can rewrite this. 1 minus 1, it simplifies to just ln of x. In here at the bottom, maybe I can write that as this. So it's not it doesn't look bad anymore, diba? X over x is 1. 1 minus x is 1 over x. 1 over x there. So let's apply this. When you look at this, it's just 1 minus 1 plus 0. It's 0 over 0. It's still type 1. When you apply the L'Hopital's rule here, so here I'll write L'Hopital's. Here I just tried to rewrite it to clean it. 1 over x. This is positive 1 over x squared plus 1 over x. Okay. Let's apply the limits as x approaches 1. So that's 1 over 1 plus 1. Let's go to number 2. When we apply pi over 2, this secant x minus tangent x. When I apply secant, basically that's cosine, right? Cosine of 90 is 0, therefore it becomes 1 over 0, it's infinity. Tangent, that's sine over cosine again. So this is type number 3. I can't do that. What we do here is, maybe guys, go back to your basic trigonometry. This is 1 over cosine. This is sine over cosine. So I just have one denominator, it's cosine. On top, it's 1 minus sine. So when I apply, that's 1 minus 1 over 0. It's 0 over 0. It is type number 1. Okay, if it's type 1, guys, what do we do? LHR. So the L'Hopital's rule, that becomes negative cosine x over negative sine x. Am I correct? So let's apply. For cosine, it's 0 over 1. Therefore, the answer is 0. And then let's try number 3. The limit as x approaches infinity of of ln x minus 2 minus ln of x over 2. So here it becomes infinity minus infinity. So that's type number 3. So what we do here, guys, is this. For number 3, you don't have any denominator to make it just like in number 1. To make it like this, we don't have an LCD. Secondly, it's not trigonometric. You can't make it over cosine, over sine, or whatever. So we have to make use of the concept of E. Note that E to the ln of x is x. ln of E to the x is x. ln E, which is actually still x. Okay, take note of this. So, if I say, let L be the limit of this one. Let L be the limit of ln x minus 2 minus ln of x over 2. If I make it, guys, like this, e to the L, that's e to the ln of x minus 2 minus ln of x over 2. Okay. And also, take note of this. This is note number 1. Note number 2, from your basic algebra, e to the m minus n is actually e to the m over e to the n. The reason being, this one, I can say that that's e to the ln of x minus 2 all over e to the ln of x over 2. Right? You're trying to solve for the limit as x approaches infinity for this. However, this one, I can rewrite that as this over this, according to rule number 1 or note number 1. Am I correct? So even before I apply the limits, I can say, that's 2, x minus 2 all over x as x approaches infinity is basically infinity over infinity. Now, this is type number 1. So from type 3 to type 1, we were able to do whatever we needed to do. LHR, I don't need the 2. Derivative of x is 1. Derivative of x is 1. What's the answer? 2. But then, guys, we transformed it. Diba? Let L be that one. What we solved for is e to the L. If e to the L is equal to 2, how do you solve for L, guys? In order to answer this, you need to apply ln of both sides. So, L is equal to actually ln of 2. This is your final answer. Because I applied E on both sides, what we need to do after getting the answer, go back. What you have here is an E to the L, right? So you need to apply ln to both sides to get the final answer. Is it clear?
Yes, sir.
Okay. Now, let's go to the last case. Case number 4 again. The reason why this is confusing is because it has 3 different forms. However, all you need to remember is that whenever it's in the exponential form, like this one, 1 raised to an exponent, this raised to an exponent, this raised to an exponent, this is case number 4. Some of you might ask, sir, isn't it that infinity raised to infinity is indeterminate? No. Infinity raised to infinity is infinity. Okay? Let's try number 1. The limit as x approaches 0 from the right of x to the sine x. So 0, sine of 0 is 0. So this is type number 4. If it's type number 4, guys, it's actually the opposite of what we are going to do. So let L x to the sine x. Therefore, in order to remove this, what we do is ln of L is sine of x, ln of x. Can you follow what I did? It's the opposite of what I did in here. In here, I did apply the ln naman. Why? In order to bring down the exponent. Okay. So I'll take note of this later on. So far, what I'll be doing is this. The limit of sine x, ln of x as x approaches 0 from the positive side is 0 times this is negative infinity. So it's now type number 2. From type 2, as I said, it might be a bit difficult to put the ln below. So what we do here is we put the sign below. It becomes a cosecant. So that's negative infinity over infinity. So from type 4, it became a type 2. Now it's a type 1. What can we do if it's type 1, guys? LHR. I keep on repeating that, so please don't forget that. So this one is negative cosecant x cotangent of x. Right? Okay. Again, it's quite ugly. Maybe we can fix this. 1 over x. What is cosecant, guys? Isn't it sine? And cotangent is tangent. So it becomes sine over cosine. Right? So let's apply. I'll force the x to be underneath. Sine squared x over x cosine x. So that this one is negative 0 over 0 times 1. So it's still type 1. Therefore, I still need to apply another LHR. If it's another LHR, guys, that means I have a negative in front. 2 sine x cosine x, and then the one at the bottom, that's the product rule. You copy the first, derivative of the second, plus copy the second, derivative of the first, and then let's apply the limits. On top, automatically, there's a 0. At the bottom, 0, 0. Oy, may 1. So that means it's 0, or basically 0, right? However, guys, take note that the 0 is actually ln 0. What is the limit, guys? Diba? So that means L is equal to 1. Let's try number 3. 1 plus 2x 1 over x. So this one is 1 raised to infinity. So it's type 4. So maybe if here what we do here is 1 over x ln of 1 plus 2x, right? We changed the form already. Okay. So let's apply. It becomes infinity times 0. It is a type 2. So what do we do? I'll just put the x underneath. If I plug in the limit as x approaches 0 now, this one becomes 0 over 0. It is type number 1. Now that it's type 1, I can apply the L'Hopital's rule. 1 over 1 plus 2x times 2. Underneath, that's just over 1. L'Hopital's rule, apply the limit, 2 over 1. The answer is 2. But then, guys, in here, take note that let L be 1 plus 2x raised to 1 over x. So ln of L right? Because I skipped this step already. I did this immediately. Take note that ln of L is equal to 2. Therefore, the answer limit is actually e to the 2.